Okay, so what I'm going to try to go through today, which is not off to a brilliant start, is how to use the event handling system in matplotlib for building interactive figures. So if you've ever used the pan or the zoom tools in matplotlib, or you've noticed, when you move your mouse around, you get that little thing in the bottom corner that tells you where your cursor is. That's all run through an event framework that is internal to matplotlib, and you can hook into it for your own purposes. So let's see. Is everyone else's demos going at about the same speed as this, or? All right. Okay, I guess I'm not sure what to do while I wait for this machine to set itself up so I can start demoing things. So who has the environment set up and is ready to go in IPython? 2 people, okay. Is everyone who isn't making progress towards having the environment in IPython set up? You should run this command, because you're going to need PyTables, because we're going to read an HDF5 file later, and you're going to need the 2.0 beta from Conda Forge. That sounds right. Oh boy.
Oh, how many gigabytes is it?
It's a lot. I wouldn't do it off your phone.
Yeah, okay.
Okay, well, this is starting off as a complete disaster, but at least it has to get better, right? So what we're going to talk about today will hopefully be a quick introduction to the event handling system. There's a tremendous amount of depth here that you could get into. You can literally write a book about it. One of the other core developers, Ben Root, recently published a book called Interactive Applications Using Matplotlib. And the blurb is, learn how Lincoln could use Matplotlib to save the Earth from hordes of ravenous space were-rabbits. Just plotting your data won't save the world, but turning your plots into interactive applications will help your users explore their data and gain greater insight into their problems. This book will walk the reader through the process of turning a simple radar viewer into a useful hazardous events tracker, so you too could spot where the space were-rabbits are going to strike next. And in addition, everything I'm going to show today is documented to one degree or another.
Does anyone have an HDMI VGA adapter?
Of course, I can't type. So this tutorial, which is on the matplotlib website, is kind of the basis for what I'm going to be talking about. I'm going to extend, the examples go a little bit off from this, but this, if later you want to read more, this is a very good resource. Right, so how is my download doing? Not great. Okay, so as I mentioned, there's a whole event system, and the way matplotlib separates concerns is that there's all the artists, which are your figure, your axes, if familiar with the object-oriented aspect of matplotlib, and that's the in-memory representation of your figure. And then that's connected up with a canvas or what we call backends, which are responsible for turning that in-memory representation into something on the screen. If you're running through ag and then to one of the to a GUI toolkit, this is what gives you the image you can click on. This architecture also allows us to swap out and get SVG, PDF, EPS, all from the same in-memory representation. So the GUI frameworks, which we ship embeddings for, all have hooks that when you provide GUI events, such as clicking or typing a key, there's a bridge from the GUI framework down to matplotlib that generates one of these events that you can then hook into and to receive and do work on. These fall down into roughly 3 different classes of events. There's what you could call active events, and this is where the button press, key press, and pick events, this is something where the user's actively telling you, I'd like to interact now. They're clicking, they're hitting a key. There's the passive ones, which are the motion notify and all the enter and leave events. These correspond to where your mouse is. So if you the XY coordinates in the lower corner, this is a hookup to the mouse motion event. And then the draw and resize events are kind of internal events that tell anything that needs to watch the exact size of the figure that it needs to redraw itself, which is mostly useful if you get into, for instance, blitting, which is a technique for making figures render faster by not re-rendering things that haven't changed. And that is an entirely separate 1.5 hour tutorial. All right. And we're still making progress. Okay. So has anyone gotten the environment installed and IPython started? Great, one person. So if you start up IPython and run %run explore 0, sorry, I'm just very flustered that this is not going smoothly.
One thing to note, if they are in on their laptop, it should have, I think, all the packages required for it. So rather than create a whole environment, just use the root.
Okay, I mean, it should work. I was hoping to show off some of the 2.0 features, which is why having people install from Conda Forge. But if you I have not tried this in a stock Anaconda environment, so we'll see what breaks. But that is an option for trying. So in 00 Explorer, this is just the simplest thing you could hook up. So the callbacks you need to register are a function that simply take in a single argument, which is the event. To be able to to capture this, if we use a global variable, we can stash this to look at later, and then we just print out all the attributes that are on this on the event.
Sorry, could you increase the font size a little bit?
Is that better? Oh, that's too much. And then the way you tell matplotlib that you'd like to register a callback to be hooked up to the event system is you need to get hold of the canvas, which is the backend that's responsible for actually drawing the figure and is hooked up to the GUI framework. And it has a method MPL connect. You give it the name of the event you would like, and then the function that should get that event. All right. How far are you through? All right. So people who have any version of IPython and matplotlib, this one should be runnable in the stock one. So if people can start playing with that, and I'm going to see if what will break. Is this just in your root one?
Do source Anaconda 3/bin.
Okay. Great. What I call it, interactive MPL tutorial. Can I install things in your root environment? So the problem here is that the packaging upstream is switched from Qt4 to Qt5 without switching all of the dependencies that default to using Qt4. And the easiest thing is just roll everything back to Qt4, at least until those things get sorted. So who has successfully run 0.0 on their computer? It's greater than 1.6 to try to force it to be 2.0. And you need the full conda /label/rc as a channel.
Yeah, I copied and pasted.
Huh.
I copied and pasted from the page. Didn't work.
Okay, then just give up and use 1.5. So if you switch which event you're looking at, you can explore through which of those events you can get at and what they look like when you get them.
You might do better to steal someone else's laptop who actually got it installed.
Actually, fine.
Your mom.
All right. All right, so we're gonna do it this way. If I can type. Hooray, okay. So, right. So right, so if you see as I click, you got these nice printouts. If you change which button you're clicking, it shows you which button. And on the mouse events, you also get, if you hold down Shift and click, no, there we go. You also get the modifier, if I can do both at once. Oh, Alt appears to be captured by the system. So you can capture the modifier keys, you can capture mouse events. Come on. So if you change the button press to key press, quit. When you it automatically reruns the file. And now as you type keys, you see the key show up. One danger, if you want to write something which looks at key bindings, be careful of the default ones. For instance, L turns your x-axis to log, or sorry, y-axis. K turns your x-axis. Save tries to, S tries to save. So you want to turn those off, which I'll show you how to do in a later example. All right, so how many people have successfully hooked up to a different event than button press? How many people have tried to hook up to a different event than button press? Okay. Okay, so we're going to move on to the next one. All right. All right, so this code at the top here just removes all the default key bindings so that we don't try to go home, we don't try to save any of that. So in the first example, we just had a function that we hooked up to the callback stack to accept the events and do something with it. This is convenient because the function, it's very easy to define a function. However, functions are typically stateless. So if you wanted to do anything where you'd capture multiple events in sequence to see if the users were doing, clicking multiple places, it's convenient to use a callable object as the callback. So here we're just simply, this is a callable class. We hook it up to the key press events, and when it gets the events, it prints them to the screen, and it also captures them in a buffer that we can look at. And then once you have those events cached, now you can start doing so now that you've started capturing things, you can at later times do computations. So you can imagine doing something like, capturing a bunch of points and waiting for a further event, like the enter key, and then to trigger some processing. So if everyone could play with this for a bit. So, an obvious extension of this is to add a method onto this, which would, yes?
I just was wondering, I'm running it under IEE Spider, and the events don't do anything, so it's quite understand. Is that the problem? Should I be not running it in?
Are you in the IPython port? Are you in the IDE? Is it loading inline?
So that's not the problem.
Is it popping the
I get the graph, but I don't get the graph.
So can you pan and zoom your graph, or is it inline just a static image? You need to switch the backend from inline to Qt. Or just use IPython is probably the simplest way to get this working. Right. So an obvious extension on this is just to take, to add a method which will print out the string the user typed in, clear the deck. So if people could play with this for a little bit. All right. Have people gotten this? Who has gotten this to at least run? Great. All right, so I'm going to give you 5 minutes. All right, so who is having trouble getting this to work at all? And I will come around and see if I can. So the issue there is that both the directed groups were doing netloop needs to be declared in Python REPL netloop, and Python takes care of a lot of the details for you, whereas the straight Python interpreter does not. So these examples all need to be run by Python. Who else is having problems? So the question was to connect, take a list, and it only takes a single list to connect. Okay. Okay, so we're going to continue. So the next thing you might want to do is in your callback functions, instead of just taking the events and blindly doing something with them, the events carry quite a bit of information, as I hope you discovered in the first step. And so now you can start making decisions about what to do based on the information in the event. So in this case, we've defined another class for handling the callbacks, because we're going to try to do something stateful again. And when we construct it, we're going to give it a line2D object. And this is just a bunch of boilerplate. So we stash the current data, we stash the line itself, and then the color cycle will be used later below. And then we connect up two methods on this object to the canvas to the callbacks, on button and on key. So if we just look at on button, the first thing it does is the callbacks are registered per axis, and axes are associated with figures. So if you've got a multi-axis figure, you might only want to accept events that happen in one axis or another. So this first test is just a check to make sure we're working the axis we think we're working in. We only want to accept the left mouse button when there are no modifiers clicked. So that's what this is checking. Where did my key? There we go. Then we're going to grab the X and Y location from the event, append it to the list, and then update the artist with that data. And this draw idle is a command that asks the canvas to the next time it's convenient for the GUI, please redraw yourself. So if we should have an empty figure. And now, as you click around, you should be able to build up a line. All right, and now the second half of this is if the method on key, well, it's just going to advance through colors and then change the color of that line whenever we hit the key C. So if we run this again, click a whole bunch, and now as I hit C, hopefully you see make it nice and thick. So now you can see we can cycle the color in response to a keystroke. So again, this is kind of a toy example, but you could imagine that if you've got some GUI button, you can click to change the color, you can click that to change the visibility. If you're interested in providing your users a way to do something to the data in response to user input. So other things that, so I'm going to give you another 10 minutes or so to play with this. Some interesting things to do might be if you shift click or right click to remove the nearest point. So if you've got users that need to build up some user input path on top of, say, an image to trace out a line, or, as a rough guess for starting some algorithm, you could try mapping the number keys to changing the line width, or using the escape key to just completely clear your data and start again. So I'm going to give you a few minutes and walk around. on the right line. It's like hoping point external limit, something funny like that. Right. Who else is having problems? Okay, so it appears most people have managed to get this running, so let's see what 3 is. Okay, so the pick event is an event that allows you to interact very specifically with artists in the figure. The keyboard and the mouse events are very general. They're anything that hits the canvas, you'll just get where those user events are. The pick event allows you to select specific. It allows you to say only fire when a user clicks on this particular artist, and then it gives you back additional information about the artist, depending on what type of artist it is. For example, for line 2D, you get back the index of where in the XY list that pick was. So if we run this, so in the title I promised time series. So the time series we're going to be looking at is hourly temperature data pulled from the BWI weather station. So what this is a badly formatted y-axis or x-axis. So this is daily averages for the last almost 2 years at BWI. And now if I click on these points, it will print out the row of the data frame. So if you look at BWI is a data frame which has all of the hourly measurements in it. There's just the temperature and the date. And if you look at BWI, this is BWI columns is the aggregated by day of the mean, mean standard deviation, min, max, and the percentiles of the temperature measured on that day. And then what's plotted here is the means per day, and it's hooked up so that when you click on it, you can drill down and see the statistics associated with that day. And so again, now if you just need to provide some rudimentary data exploration, where the marks on the screen aren't quite enough, you want to provide a bit more context, or you want to report out the name of something, or you've got paragraphs of text that go with each point. Using a pick event like this, which I'm going to bring it up again. Using a pick event like this, where you just use the index to slice into some parallel data structure to your XY points, is a very powerful way to quickly provide additional user feedback. So, I guess this, so people can play with this. I mean, the things you could try doing in addition to what it already does. I should show you labeled data. So looking at this, you can start to see some interesting outliers, like zoom in a little bit, like those. So there's a couple. In the source code in the file, there's some little helper functions, such as label date, which will just put an annotation on a specific date. Of course, I can't type. This would have been funnier if I could type faster. And why didn't that work? managed to pick the one cold weekend last October. So I'm going to bring the code back up. If people want, I'm going to walk around again while people play with this. So, yeah. So, all right, if people manage to get this example to run, this is what requires PyTables. All right, so who needs help? No one needs help. Are you all bored and checking your email? PyTables. So, so there's an HTML5 file in the repository that is the extracted data from NOAA. So where this came from is, again, you can get hourly logs by the year per weather station, which contain, you know, a tremendous amount of information per line. And I've just gone through and just pulled out just the temperature. If you look at 99-get the data, that's the code that will go out and download the files from NOAA if you wanted to reconstruct this for a different weather station. All right. Anyone have questions? All right. Okay, so if we move on to the next file, which some people already have done. Come on. So this isn't so much an interactive example and more of a suggestion of how to get the most out of the library. So the underlying functions that we expose in matplotlib are very low level, right? We expect a single array for x, a single array for y, and we're providing very low level, glyphs or marks to steal language from other plotting libraries, and we strongly suggest that you write yourself helper functions that use one or more of the underlying plotting methods that know something about the structure of your data. For instance, in this, this plots an aggregate error bar. This is creating an error bar. It knows that it's getting in a data frame which has an index, a mean, and a standard deviation that you'd want to use. And then it fills the region between, pulling the min and max columns out of your data frame. Right, this is very non-general. However, it's very tuned, to this particular use case. And you get a graph that looks like this, which it obviously has much more information in it than just the single plot from the previous example. But again, there's no native function that will do this. So you need to write your own to build that additional functionality in. So at this point, so I'm not even going to show you what this does before looking at the code. So while I was walking around, someone asked, could you click and cause it to plot? So this is a couple hundred lines of interactive code that ideally should be you should have been able to, ideally should be understandable after the first half of this tutorial. If you click on, so that the top panel is the temperature aggregated by month. If you click on any of the months, come on, you get a graph of the temperature in by day. And if you click on the day, you get the graphs hourly in the third plot. And then, so now this is only showing how to add data. If you click on any of these down here, well, or all of them, anything that gets picked will remove itself. And if you shift click, I'm holding on the shift key and clicking on these, which will remove the months. So now if you were interested in comparing all the summers, you go through and get all the summers. Or comparing February and August. So, so if people can people get this to run? All right. So I'm now going to just talk through what this code does, and then for the rest of the tutorial, just turn you loose, playing with it, and I'll walk around and answer questions. All right. So the first thing in here, this is just a helper function to load the pre-processed data. That's interesting what it's done with that Unicode. This sets up the figure with the 3 axes that we're going to need, labels them, turns the grid on, and makes sure that the limits are set correctly. The share y means that all of the y-axes of those 3 plots are linked. So if you zoom on one, the other 2 will also zoom. And then this sets the x limits to correctly scale to whatever to either to 32 days for the month or 24 hours for the time. This plot aggregated error bar is just our friend from the last example that just creates those band plots. And then this aggregated time trace is the object that takes care of both managing the data and then hooking up hooking up into the events and plotting as required. It takes in a fair amount of arguments. So hourly data is the unaggregated data. The label is if you name it. So now if you want to create multiple time traces in the same figure, so if you want to compare BWI and JFK, for example. And then it takes in the 3 axes that it's going to use for the year scale, the month scale, and the day scale. In this particular case, they're all in the same figure. However, there's no particular reason it has to be the case. You could have each of these in their own window. Or if you're building out a custom GUI, you could have these in very different parts of your GUI, and they still be able to talk to each other. So the init is all just entirely bookkeeping. And then we register 3 pick event messages for each of the 3 axes. So the simplest one is in the top axes. We just check to see, are we in the right place? If we don't have an artist for whatever reason, bail. And otherwise, use the index, pull that index out of the aggregated by month data, figure out what the month and the year are, and then pass those to this other plot t by day, which goes through and does the data munging required to pull the month out of the monthly aggregated data, and then plots it. And then this here, so GID is a user field on all matplotlib artists that's for whatever you want to do with it. So it's a global identifier. Internally, we don't use it at all, but we carry it around everywhere, and it also gets up in the vector backends. So if you want to label an artist for your own purposes, this is a good place to do it. This is as opposed to the set and get label, which is the label of that artist that we use when generating the legends. And then the on month pick is almost identical. We check to see if we're in the right axes. If we're holding down the shift key, go through and remove that artist. Otherwise, walk through, pull the year, month, and day out, and pass it to a by hour plot function, which just pulls that 1 day worth of data from the raw hourly data we handed in and just plots it. And the simplest one is the daily on pick, which just if it's been picked, delete yourself. And then at the end, to actually create these things, we use setup temperature figure to get our figure and the 3 axes we're going to use, pass it all to the init method, and then just put a nice label on top. So hopefully this has shown you the power that you have through this event system to build very rich interactive graphs. The cost is there's still, you have to do a fair amount of work to get it to work as you need, but the power is there if you need it. So I'm just going to walk around and answer questions till the end of the tutorial.